Working with large or small numbers can be easier if we write them with powers of 10. Consider this number. We could count the zeros to figure out exactly what it says, but it is much easier to recognize and much more compact to write if we write it with powers of 10. Now we know immediately that the number has 9 zeros after the 6, which means it is 6 billion. This format, in which we multiply a number between 1 and 10 by a power of 10, is called scientific notation. We can use a simple process to convert any number into scientific notation. Let's take the number 3042 as an example. We start by recognizing that this number really has a decimal point at the end, even though it wasn't shown. Because scientific notation starts with a number between 1 and 10, we need the decimal point right after the 3, which means we need to move it 1, 2, 3 places to the left. Each place represents a factor of 10, so 3 places represents a factor of 10 to the third. Therefore, 3042 is the same as 3.042 times 10 to the third power. To check that this is correct, remember that 10 to the third is 1000, and multiplying 3.042 by 1000 does indeed give us our original number. We can also use scientific notation for numbers smaller than 1. Consider the number 0.00012. We need to start with a number between 1 and 10, so in this case we need to move the decimal place from here to here. That means we need to move the decimal point 1, 2, 3, 4 places to the right. Since we've gone to the right, each decimal place represents a factor of 1/10, or 10 to the minus 1, so the 4 places represent a factor of 10 to the minus 4th. That is, 0.00012 is the same as 1.2 times 10 to the negative 4th power. Again, we can check. Notice that the 1 in our original number is in the 10,000ths column, and 10 to the minus 4th is indeed 1/10,000th. To summarize, we use 2 steps to convert a number to scientific notation. First, we move the decimal point to follow the first non-zero digit. Notice how we did this in our 2 examples. We then determine the power of 10 from the number of places the decimal point moved. The power is positive if it moved to the left, and negative if it moved to the right.